Morning, boys and girls. Welcome to our Friday lesson. We're going to be doing some experiments today, so I hope you have your scientist brain turned well and truly on. Today we're going to be learning a bit about two topics, really, gravity and friction. So we learned a little bit about gravity firsthand last week when we were exploring how eggs drop, and we're going to be learning a bit about friction this week. So we did a bit of reading, and hopefully we're going to be able to use that information to inform our experiment later. Before I take a look at that, I'll just take a quick look at our Kahoot results from this week. So we had two Kahoots. We had one on Wednesday. So well done everyone who took part. I think about 45 attempts on it. So people did really, really well. Let's see whoever Hairy Giraffe and Stellar Wolf is. Sorry about the names, guys. Hopefully for the next quiz you'll be able to enter something that actually tells me who you are. Did so good. They came within, wow, must have been only seconds. I was quicker than them. So we got the same marks right then. There's loads of people here on 90% doing really, really well. Well done, Posh. I can't really tell who the rest of the people are. Ronan doing very well there as well. And Circle Band, that's fantastic. Well done, really good, guys. And obviously the other animals in my class are doing very well. Not to call you animals or anything like that. But well done, everyone. There was fantastic results here, so I was very, very impressed. Take a look with today's. So I imagine there's less people having done today's one so far because it's early yet. But well done, not Jack, whoever that might be. You got a great result there, and whoever Rowdy Hedgehog is, good stuff. Maybe again, guys, clues to your names, please. Lovely work, really, really well done. And if you need any help with that, let me know. But until then, let's jump back into our gravity. Oh, hey, that's a great point. Okay, moving on. Gravity and friction. Okay, what are our objectives today? We're going to find out what happens when there's friction between two objects. We're going to experiment ways to increase friction, and we're going to record our results and compare them to other results. Well, we'll see about that. Okay, so let's talk about gravity first. So thinking back to our egg drop, what happens when you drop your egg? Well, if you're on Earth, your egg falls to the ground. So gravity is a force that's pulling us down, and the bigger the object is, the bigger the force. That's why if we were standing on Jupiter and you dropped an egg from the same height, it would fall quicker because there's a stronger force pulling it down. Whereas if you're on the moon, it would fall slower because there's a stronger force pulling it down. But on Earth, everything falls down at the same speed when you drop it. So it says, does it affect all things equally? Yes, it does. So if you drop a cannonball and a marble from the top of a tower and you line up so the bottom is lined up with the bottom perfectly, you drop them both off the tower. They'll both hit the ground at the exact same time. And now you're thinking, yeah, but Mr. Fitzpatrick, it doesn't work on everything. What if you dropped a bowling ball and a feather? They wouldn't fall at the same time. They wouldn't hit the ground at the same time. The bowling ball would hit way, way before the feather. You're absolutely right. So there's something else causing it to slow down that feather. If you were to do it in space or on the moon where there's no air, that's a clue there. If you drop a bowling ball and a feather, they'll both hit the ground at the same time. But on Earth, where we have air, there's something slowing down the lighter object, the feather. Okay, let's take a look at what that is. It's friction. So let's talk about friction. What is friction? Well, friction is when there is a movement of two objects rubbing off each other in some way. So the classic example is with your hands. If you rub your hands together, you feel the heat coming off it. So that's the friction. So that's the movement energy of your hands. Your hands are being slowed down by rubbing off one another. And think about another time if you've ever been cycling really, really fast on your bicycle and pulled the brake really hard and then put your finger to the brake, you'll find it's hot because all that speed energy has just been turned into heat energy by friction, and it's slowed down your bicycle. Okay, so friction is the resistance of motion when one object rubs up against another. So you can see there's a pushing force, and friction pushes the opposite way from going. So whatever way you're going, friction is something that slows you down. So obviously that could be a negative thing if you're looking to travel fast, but if you have a reason to slow down or stop, like pulling the brakes, that can be a really, really useful thing. Okay, so can you give an example? So I'm sure you can think of things that rub off each other, and I'm sure you can think of many there. So I'll let you have a little read about this air resistance here. So this is something we're going to be talking about a little bit today. So air resistance is a force that's caused by air pushing against a falling or moving object. It is known as drag. Okay, you often hear that when you're talking about cars or different things like that. Air resistance acts in the opposite direction of the object. So air resistance is a fluid friction. So you might remember that from our reading during the week. So two factors that affect air resistance are the size and shape of the object. This means that a larger shaped and sized object will have more air resistance acting on it. Okay, so let's take a look at our activity, say. So what we're going to be doing is we're going to be slowing a car. So if you've got any toy car or Lego car or anything like that at home, what you're going to be doing is you're going to be sending that down a track. So you're going to be lifting it up, which is going to give it some energy, let gravity pull it down, and then you are going to, well, let go of it and see how fast it travels down your track. Maybe do it a few times, and then you can time it and see how quick it goes. And then what we're going to do is we're going to make some modifications, so some changes to the car. So let's take a look. So we're going to try and slow down the car as much as possible, so create as much friction as possible. You are allowed to modify your car to slow it down, so make some changes to the car to slow it down. The wheels may not be removed, so you can't take away the wheels. It's not a car if it doesn't have wheels. The four wheels must be able to rotate. If it's a four-wheeled thing, the wheels must be able to turn. Okay, so you can't just block one of the wheels with elastic bands or something like that to stop it turning. That would slow it down a lot, obviously. All four wheels must be on the ground, and you might find this video a bit helpful. I'm going to show you a video now in a second. Because if you want to crack on straight away and have a go pause video here, that's fine. Or if you want to take a look at a few clues that I'm going to give you that might help you, that's great too. Okay, let's take a look at this together. Hopefully it works.
Right side of your screen there, a great looking Daytona. It was fast, maybe a little too much.
So here they're going to try and slow down.
No shoots. That's the bad call because there's still no shoots. Next up will be the beach. That big old wing didn't slow down enough, did it, Paul? No, but it must have put the back end down nicely like it's supposed to. You'll see that full series coverage next.
So there was three things that tried to slow down these three cars today. I wonder if you can tell me what they are. Okay, so the first thing was the first car had its parachute. That slowed it down really, really quickly. Really good if you got that well done. The next one is the wing. He said the next one was the sand even, wasn't it? So if it was traveling on rougher terrain, it would create more friction. I wonder if it's the same if the wheels were rougher. Would that create more friction? What about the wing? So he said the downward pressure on the wing would slow it down, keep it pushing into the ground and create more friction. Okay, so that might give you some ideas. In a second now, if I get my technology working, we're going to take a look at what I managed to come up with and my experiment. I hope you enjoy it, guys. So this is my car today. As you can see, it's a real speedster. The fastest car that Duplo can manage. Will the red wheels make it faster? Probably not. But let's see how it gets on in this challenge. Okay, so here are the modifications that we've come up with. So, we've added more weight in the form of blocks. In theory, that should increase the amount of air resistance. I have this metal paper clip that I'm using as a brake. And those red wheels were just going to be way, way too fast. So I decided that I'm going to get some Play-Doh and cover the wheels in Play-Doh. I might try it with and without Play-Doh, just to see what the difference might be. Okay, let's see what happens. Yep. I hope you enjoyed this experiment. Show me your uh, version of the experiment and explain your modifications and tell me if there was any time difference. If you had a timer, obviously that's the best way to compare all the different times. Which of the modifications do you think was most important for you, for me? And I'll leave you with a blooper that I made in my one. Okay, Slán, hope you're doing well.